Life and quantum physics take place at two different ends of the natural spectrum. Living systems are warm, wet, and complex. They need their environment to survive, and they're strongly embedded in their environment. Quantum systems, on the other hand, need to be carefully isolated in order to be manipulated and engineered and addressed properly. In this paper, we put the two together. We experiment with a living system together with a quantum system. It's a superconducting quantum bit and a tardigrade.
Tardigrades are microscopic animals living in a range of habitats across the globe. All tardigrades need to be surrounded by water in order to be in their active and feeding state. Many tardigrades, however, tolerate extreme conditions such as desiccation and freezing, and they do so by entering a state of suspended animation, which is called cryptobiosis.
We model the tardigrade as a finite collection of induced dipoles from the electric field of the qubit. This way, we can treat the tardigrade as a finite collection of harmonic oscillators, the qubit as a two-level system, and their coupling by this interaction Hamiltonian that describes the electric field coupling between the qubit and the tardigrade. With this new Hamiltonian, we can explain the frequency shift observed in the first part of the experiment. This is because the eigenenergies of this new Hamiltonian are now the dress states. The dress states have different energy levels compared to the bare qubit and tardigrade. In this way, the energy gap is now changed. From the second part of the experiment, we reconstruct the density matrix of the qubit A tardigrade and qubit B system by treating the tardigrade as an effective two-level system. From this reconstructed density matrix, we calculated an entanglement for different coupling strengths. Other models were also discussed in the paper. The two qubits were placed in the cavity as such. One qubit was placed below, and the other was placed on top of it. In the experimental runs with the tardigrade, a tardigrade was placed on the uppermost qubit. The qubits were then sealed in the cavity and placed in the fridge. Using this setup, we characterized the qubits over two cooldoms. Firstly without the tardigrade, and then with the tardigrade. Our experiment can be divided into two parts. In the first, we observe the frequency shift between the bare qubit without the tardigrade and with the qubit with the tardigrade. Furthermore, the frequency of the second qubit without the tardigrade was unchanged. This shows an interaction between the tan and the upper qubit. In the second part of the experiment, we applied pulses to generate Bell states between the dressed qubit A tardigrades with the qubit B system. These pulses entangle the upper qubit A tardigrade dress system with the lower qubit B.
After we have performed all these experiments described earlier, which took in total 420 hours, where the tardigrade was just barely above 0 Kelvin, we brought it back to room temperature and ambient pressure. Then we placed the tardigrade into water and were able to bring it back to life. This was the hardest part of the experiment, to find the right procedure leading to the survival of the tardigrade. In fact, it was the world record for any living system in such extreme conditions to be revived. This also begs the question, was the tardigrade alive during the experiment?
Well, that depends on your definition of life. At first sight, life seems to be a continuous process. So when an animal was alive before the experiment and after the experiment, it was also alive during the experiment. But to many biologists, metabolism is a prerequisite for life. From this perspective, the animal was not living during the experiment. It would therefore be desirable to design setups where entanglement is established with metabolically active animal. It would also be valuable to measure the time independently of the qubit so that entanglement is determined with less modeling, say via entanglement witnesses. Altogether, we hope the tardigrades will visit quantum labs more often.